Hello and good morning. My name is Hans-Jörg Schmidt. I'm the developer of fx-Calc, a scientific calculator for Windows, and I'd like to take the opportunity to introduce the program to you this morning. I'm from Germany, not a native speaker, so please be patient with me. And let's start with the introduction. The program itself starts with a window which looks quite much like a scientific calculator. We have different sections in this window. For instance, the most important one, which is this editor field, where we have to type our calculation. We have certain buttons here in this area, mainly the standard mathematical functions in this area, the basic calculations in this area, and numbers, of course, and a few extended possibilities in this area, just like working with values in memory or using a constant database, a function database, and calling conversions. So those are the main the main fields or the main areas in this program window. Last but not least, we have this area where we have 5 input fields, editor fields, text fields, where we can type in some specific values, and we will come to this a bit later in this introduction. And last but not least, we have this area where we have options to use different argument ranges for trigonometric functions. We can enable the calculation with complex numbers, and we have certain possibilities to run graphics, function plots, and solve functions and analyze functions. So that's the basic overview. And let's start with some examples here. The first one is already on screen, 4 plus 9, which gives you 13. And let's multiply 9 with, let's say, 3. That gives you 31, and that's one of the very important points to mention. fx-Calc is using a so-called direct algebraic logic, which means that the calculation of 9 times 3 is being calculated first, and then the 4 is being added according to valid mathematical rules, which say that the multiplication has to be performed prior to adding anything to the equation. So if you want to make it differently, just like 4 plus 9 times 3 in a way that you finally get 13 times 3, you need to use brackets. And we just do this. And we see that we now get exactly the expected result from this calculation. By the way, it doesn't matter if you have the star for the multiplication in this equation or not. fx-Calc is determining automatically if multiplication would make sense at this specific point, and is doing the right thing automatically. So of course, you can use whatever number of brackets in this in your calculations. It doesn't matter. And the next thing I'd like to show you is how we would use functions. So I do this the way that we have finally a result of 30 in our calculation. And by the way, that's another advantage of having this editor field, because you can modify your calculation as needed, and can adjust it to your demand, which makes it quite efficient to calculate multiple things with fx-Calc. So if we, for instance, want to have the sinus of 30 degrees, we can use one of those buttons here, which inserts automatically the sinus function. And what we have to do in this case is to make sure we set the brackets correctly. and yeah, then we have to switch to degrees, which gives us the dot 5, the expected special sinus value for 30 degrees. Yeah, and that's exactly how it works for whatever calculation in fx-Calc. Yeah, what we could do now is, for instance, to use this calculation to calculate a square root. Yeah, so if we would say, for instance, 16 powered by the result of the sinus function. Oops, that was the wrong character. Yeah, 16 powered by a half is 4, because that's similar to the square root. Yeah, so with other words, you can bring whatever kind of calculation into this window as long as it's being supported by the inbuilt functions of fx-Calc. Yeah, that's great functionality. Another very important and very interesting capability, which is quite specific for fx-Calc, is the use of self-defined functions. And to make it easy, we have this button here, and if you push this button, you get an empty function, more or less, on screen. And you can say f of x, for instance, is x, or the square of x. Yeah, and if you do this, you can see that fx-Calc is automatically enabling this input field with the variable's name, x. And what you can do now is to type your arguments. Yeah, so if you type 2.5 for x, it calculates automatically the correct result. Yeah, and if you say, okay, I have another one, which is set, if you want, then you can say, okay, what do we do with set? We add it, yeah, simply, and yeah, if we put another argument for set in here, then we get immediately the result for this function. Of course, that's a very easy example, and what we can do now is to say, okay, I have a function which I use more frequently. Then we can open the function database and we can add a new function. Yeah. So what I can do here is to say I copy this function from calculator, call it whatever, in this case simple. Yeah. And then I say add function. And at this moment, I have this function in my database and can call it by simply double-clicking, simple example, to reuse this function and calculate its value by typing in the arguments in those fields here, which are being automatically enabled by the variable's definition. The good thing is that you can define functions with up to 5 of those variables if you want. Yeah, that should be sufficient to satisfy whatever demand in this case. Let me now show you another capability. That's the iteration for p. By double-clicking this stored function, I get a very specific type of function on screen, which is basically a sum iteration where I would calculate a sum starting from 0 to 1000 steps for the defined sum function as shown on screen here. And that's a well-known p iteration. And if you would start this, which we always have to do by a run or run check for sums and products, then it calculates or it iterates p to a certain degree, and it's very close if you look at the result. Yeah. So I think this is a good introduction to the main capabilities. Furthermore, you have the possibility to work with constants stored in a constant database. You can extend those constants as desired by adding, changing, or deleting constants in this little database as needed. And yeah, I think that's enough for the basic capabilities. Let's follow up now with 3D surfaces. That's one of the extended capabilities. And if I open this window, then I can see already a predefined function and predefined parameters, which allow me to see immediately the result of those function and the defined parameters. And I can turn it, yeah. I can change colors if I have to, yeah. If that looks more nice for myself, then I can change it this way. I can switch on automatic moving of or animation, kind of animation for this surface, and I can show the grid, which becomes more obvious if I reduce the number of triangles being used in this specific surface. So then, of course, I can use another function to show another surface. Yeah, a very well-known one is maybe this one here. By simply changing it, I can show it. I can switch on the surface again, and can stop moving it, and can rotate it as I want to see it. Yeah, that's very simple. I can use those specific values here to adjust the angle for X, Y, and Z for the axis, and I can zoom in and out as desired. Yeah? So it gives a very nice impression of a surface of a specific function, and I can do exactly the same for vector graphics, where X, Y, and Z are defined by functions for R and phi as polar coordinates. Yeah, and this little example gives us here a quite famous result, because that's the well-known Möbius ribbon. Yeah, so yeah, very nice, very interesting, and I can sharpen the picture by increasing the number of triangles being used in the presentation. Okay. Yeah, that's about 3D surfaces. And then another one is plotting functions of just one variable, or even parametric functions. And if you look at the example again, we can plot it immediately by just switching to the plot area. We see the function. And now we have a very interesting possibility, which is to see the numeric first derived function which belongs to this function. And if we go to the plot area again by just switching on the derived function, we see the derived function here in magenta on the screen. So another very interesting and unique capability of fx-Calc is to work with complex numbers. If we, for instance, take the square root functions and would say, okay, we take, for instance, 5 minus x, just as an example, and we look at the plot area, we see the function, and its derived function. But what we can do now is to switch on the complex view. So how would the complex part of this function would look like? And if we look into the plot area, we see the imaginary part of this function. So fx-Calc enables us to see how a function result in the complex numbers area would look like. Yeah, that's a very unique functionality. So, and finally, just while we talk about square root, yeah, we could as well do a very specific thing, yeah, because if we would change this one here, this example, to make it a circle, yeah, that would be more or less a circle, yeah, and I switch off the complex and the derived function, and we look at the result, we see a half of a circle. And the reason for just seeing half of a circle is that the typical result for a square root function is positive. But of course, it has two results, and the second result can be enabled by just enabling this checkbox. And if we look at the plot area again, we see the circle. Yeah? And this is as well one of the unique functionalities of fx-Calc, so that you have options to show things in a very different way than usual. Very interesting, I would say. So, and last but not least, the possibility to show parametric functions. In this example, we have again our function of x extended by a. A is in this case our parameter. You can specify the number of functions to show. That's in this case 10. The maximum is 40. And you can define the start value for the parameter and the end value for the parameter. And finally, the colors. And fx-Calc is automatically calculating a for the different functions, and is showing you the colors and the parameter a and the different functions, so that you have an idea how a is finally impacting your behavior of the function. Okay, that's about 2D plots. Then you have a solver, which is very much the same as the root calculation functionality in the analyze part, but I will come back to this a bit later. So basically, it solves the function for a specific target if possible. Yeah. So if I would set the target to 5, for instance, yeah, and would scan the interval for solutions, I would get 6 solutions. Yeah. For those solutions, the function would return 5 as result. Yeah, very easy. Yeah, that's about solving functions. And the most powerful part of fx-Calc in my eyes is the analyze function. If you look, for instance, at this mathematical expression here, we see a trigonometric function combined with something that would lead to a pole point. And if we click on the full analysis button here, we get immediately the picture with all the interesting points included. In black, we have the roots of the function. In green, we have the pole points of the function, and that's again one of the unique capabilities. It's being calculated by analyzing the function and calculating partly roots of the analyzed function. And we have the extreme values of this function in the specified interval. And of course, we can then look at all those results in detail and can take over the results by simply clicking on this button. It's being transferred into the clipboard, and you can use it, for instance, in Excel or Word for whatever purpose. Yeah, another thing is that you can calculate integrals by just specifying your lower and upper limit. The lower and upper limit, by the way, needs always to be set on the first tab, because that's the tab which specifies the parameter for this complete analyze functionality. And another interesting capability is the tangent, where fx-Calc provides you the possibility to calculate the tangent of a function, the tangent function of a function on a specific point. Yeah? The first interesting capability is to take over this calculated tangent function to the calculator window and to calculate specific results for this tangent equation. Yeah. But another interesting thing is, of course, to perform the Newton iteration step by step, which is being used to calculate roots. And by clicking on this button, I do always the next Newton step. Yeah? And if you observe the corresponding result for the function, you see how it gets closer and closer to 0. Yeah? So that's the maximum precision that I can achieve in this calculation. So from my point of view, very powerful and provides very interesting results, specifically if you're in education or if you're an engineer or whatever who needs to deal with self-defined functions and with optimizations and all this good stuff. This provides you a very powerful capability to do this as efficient as possible. And last but not least, we have a regression module, which provides you, again, results or the function resulting out of, for instance, measured data. That's finally the function that would represent those data points as much as possible. And you can simply add further points to those data. Of course, my example is quite stupid because it's really resulting in a poor representation of the data, but it is as it is, yeah. And the important point is to realize that the coefficient of determination is much less than 9. And if that's the case, then it's a good question if this function is really representing the data. But anyway, it's just an example. And what I can do now here is to pass again the function into the calculator and can work with it again. So again, another interesting capability. This table, by the way, is able to talk to Excel via the clipboard. So you can copy data in Excel and can pass it directly into this table here, which makes it maybe a bit easier to handle bigger amounts of data. Yeah, well, that's almost everything. There's at the end this tiny button here, which leads you directly to the homepage of fx-Calc. The intention is to give you the possibility to read the documentation, which provides you with almost all important information to work with this calculator. And even more, because at the end of this documentation, you will find an extension which talks about the numeric methods that have been used in fx-Calc. Those methods have been adjusted in a way to make them more stable. And if you compare fx-Calc with other products on the market, you will realize that fx-Calc is even more stable than some of the professional products, specifically if it comes down to the calculation of roots. And the background is that it's transforming functions if needed to come to stable results. Yeah, well, that's all about fx-Calc for the moment. I hope it was not too boring. And my other hope is, of course, to get some feedback if something should go wrong. Yeah, nothing is perfect, but in my eyes, fx-Calc is, after a few years of development, one of the best calculators for Windows, and provides you a very powerful tool for your calculations. So all I have to say is, have fun with it. I hope it saves you some time sometimes. And yeah, I wish you a nice day. Thank you very much.